the double angle formulas. Our first double angle formula is for the sine function. The sine of 2a equals 2 sine a cosine of a. And here's an application of that. Suppose that we have the sine of theta equals 12/13, and theta lies in quadrant 2. Find the sine of twice that angle, theta. When you look at the formula, which I've reproduced for us, we see that the right-hand side of the formula requires that we know both the sine of our angle and the cosine. Now here we're only given the sine in the information, so in order to find the cosine, we're going to go through what we normally do, a little bit of right triangle trigonometry. Working over here, we're talking about quadrant 2, so if I place the angle in quadrant 2, it would be like so. Drop down a vertical line. And there's the theta we're talking about. Now this information says that the sine equals 12/13. And we know that in relation to theta on this triangle that the sine is equal to the opposite over the hypotenuse. The opposite and hypotenuse I'm now labeling. Let's find the Pythagorean theorem to get the third side here, x. X squared plus 12 squared equals 13 squared. X squared plus 144 equals 169. Taking away 144 from both sides, x squared equals 25. And x would be 5. Could say x would be plus or minus 5. Normally when we do the Pythagorean theorem, we're only thinking in terms of the positive value. But when it's a question which is placed in the graphing system that we're used to, we have to look at the quadrant to determine the sign. And notice that x here would have to be equal to a -5 since that angle is in quadrant 2. We go left on the x-axis and up on the y-axis. Okay, now we know what the sine of that angle is. Let's just jot down what the cosine of that angle is. We look at the triangle. Cosine equals adjacent, -5 over hypotenuse, 13. And now we're ready to do the problem. The question we've been asked to find is the sine of 2 theta. And according to this formula, it would be 2 times the sine of theta times the cosine of theta. Well, that is 2 times 12/13, you were given that, times -5/13, which we found. The denominator, 13 times 13, is 169. The numerator would be 2 times 12 times -5. 2 times 12 is 24, times -5 turns out to be -120. So the sine of twice our angle is -120 over 169. There are three double angle formulas for the cosine, and you might figure, why have 3 if we only need 1? Well, what you can do is you can select the formula for which you have the right information. You'll see that what I mean by that in this next example. Suppose the cosine equals 24 over 25 and theta's in quadrant 4. Find the cosine of 2 theta. Well, if we approach it like the last problem, we'll probably would just go off to the side, draw our triangle, solve the right triangle. But if instead we look at the formulas we have available to us, notice that the middle formula here is something that we already have the information for. All you need there is the cosine of your angle. You have to square it, but that's just arithmetic. So by selecting the second formula, we would have that the cosine of 2 theta equals 2 cosine squared theta minus 1. Now, cosine squared is just the cosine value squared, so we would plug in 24 for 25, and we would subtract 1. So we didn't even need the sine value by selecting the middle formula there. Now we certainly have some arithmetic to do. This would be 2 times, and when I square both these numbers I get 576 over 625. That's minus 1. Well, if you next multiply 2, now it only goes to the numerator, 576, you will get 1152. Kind of messy looking, isn't it? There. 1152 over 625 minus 1. And then just, remind yourself that when you're working with fractions, adding or subtracting, you want a common denominator. And the number 1 is anything over itself. So 1 is the same as 625 over 625. Finally, you can subtract the numbers in the numerator, which will give you 527. And you keep the common denominator. And there's our answer. Pretty complicated looking answer. But it wasn't really that bad to get using the correct formula. Okay, we're going to finish up this lesson by looking at a double angle formula for tangent. Just one here. And I figured just for the heck of it, let's not do this example using the coordinate system. Let's just do it as a straight right triangle trig problem. Okay, we see theta and we see a 3, 4, 5 triangle. And we have to find the tangent of 2 theta. So it's going to be equal twice the tangent of theta minus over 1 minus tangent squared theta. Well, we need tangent of theta to answer this question, but that's easy enough. Look at our triangle. Tangent of theta, remember SOHCAHTOA, tangent is opposite 3 over the adjacent 4. So, plugging that in, this will be 2 times 3/4 over 1 minus that tangent squared. Now in the numerator there, if we multiply 2 times 3, that's 6 over 4. But 6 over 4 will reduce to 3 over 2. And the denominator, that would be 1 minus 3/4 squared, that would be 9/16. Now based on the last example, you should know what I'll do in the denominator. I'm going to make 1 be 16/16. 16/16 minus 9/16 gives 7/16. And to finally finish it off, we will multiply by the reciprocal of the fraction in the denominator. We could cancel diagonally. 2 and 16 makes 1 and 8. And we will get 3 times 8 is 24 over 1 times 7 is 7. So we do get rather messy looking answers when we use these formulas. Well, good luck with that, folks. Signing out.